Yeah.
That really has nice 3D graphics in it.
Right. No, one of the neat things is, of course, the concretions are often barren, but a lot of times, if you look at them enough, you'll find some beautifully preserved fossils. Remember that the pattern in the cycle is that the sedimentation rate is actually increasing towards the top, up to a point, and then it suddenly shuts back, right? So actually, the stuff that's below the top of the cycle is actually deposited super fast, I think, in many cases. And that's why you get some really beautiful things. And I would focus attention on those intervals just a little below the limestones and see what more could be gotten out of it. So it's very sparse because the sediment was so diluted, you know, so much sediment, so few fossils. But when you do find them, they can be extraordinary, as you know. I'm sorry, there was another question over.
Well, I have a question.
More could be gotten out of it. So it's very sparse because the sediment was so diluted, you know, so much sediment, so few fossils. But when you do find them, they can be extraordinary, as you know. I'm sorry, there was another question over.
Well, I have a question. I always wonder why the large bryozoan colonies don't go up like a coral colony, go up through the layer, somehow go up through the layers, because it seems like it would have been above the surface enough that they'd be able to withstand these storm events and continue growing in a large, 10 feet colony.
Yeah, it didn't seem to happen. I think I've seen a few, 10-centimeter ones still standing up in some places. But generally, I think the bryozoans were growing during it's still relatively slow sediment. Remember, at least I've found that a lot of them are pretty close to just above the top of the limestone. And in that time, I think it was still relatively slow. Bryozoans are pretty stony, and they can handle kicking around for a while without being buried. So I don't think they were buried alive, a lot of those, and they just got toppled over. But I do think that time, right, you got sometimes even a hard ground on top of the limestone, the water's really clean then, and the water may be also rising. I didn't talk about sea level, I think it may be rising, and that may be just the perfect time to grow little reefs. And if you look under the Waldron shale, to take another unit, you get little reeflets coming up sometimes off the top of the Laurel. And, I think it's, again, at that critical point where sea levels just start to rise, the water's still really clean, it's a perfect time to build bryozoan colonies and things like that. But I don't think they're buried too fast. Thank you.
I have a question. When we're going out and collecting these beautiful layers of various brachiopods and the clusters and clusters of brachiopods, is there an average age what that represents, what we're looking at? Is it decades, centuries?
You mean, well, how thick of clusters? Are you talking about just a single layer? So
yeah, just a single layer. Yeah.
I think those may represent just a few generations, so probably less than 100 years, where the shell's just building up and then getting buried in those cases. And as you say, some of those are beautifully preserved, too. I've even seen sourbees in not everyone would agree with this, but what I think might be their life position concave upward in some of the mudstones. But, when you see them in the limestones, they're always, I would say, flip. Some people think they grew. But, some of those little patches in the mudstones are really beautiful because they really don't represent much time. I think they represent, you point out, they're patches. So you're getting strong enough sedimentation, fast enough, you can actually preserve some of that mosaic that I talked about. And you see a little patch here and a little patch there. But when you get to those limestones, it's all kind of smeared and averaged out by many storms, I think. Any other thoughts or questions?
No. You find it like this, and you're saying in the life position like this?
Well, yeah, I think so.
What is the basis of that? This just doesn't seem logical to me that the life position would be a position that would crack dirt and shell every time it opens.
Well, you got a shell like this, and many times they have even a slightly upraised rim. The dirt that you speak of that would accumulate in them, probably not too much, would actually probably help to anchor them in place and actually protect them, make them camouflage perhaps, and so on. And plus, in this orientation, you've got the valve edges sticking up so they can draw currents in and so on. You put that guy over. Now, with apologies to Dave Meyer, I know he thinks these this way, but I say, look, you really want to have your openings where the feeding currents are trying to go in, right stuck down into the mud. Much better to have them raised up than to have them pushed downward. And sometimes when you do see what must be bryozoans that grew on during the lifetime of your brach or corneolitid worm tubes, you'll see that they're oriented with let's make them cornulids, so that their apertures, their openings are towards this. Well, in this scenario, those little ice cream cones are going right down into the mud. In this scenario, that makes good sense because they would be coming up. So, I mean, granted, I know it's true that if you look at the total amount of encrusters, there are more encrusters on the convex side than the concave side. But I think that's because that was mostly covered with sediment during the lifetime. And I think that the vast majority of shell hash beds you see were processed by currents during storms. And so, yes, they were flipped to that position. But, you know, not everyone agrees. It's okay. Yeah. All right. Well, thank you very much.